20% of the world's oil moves through a waterway 18 miles wide at its narrowest point. Iran knows this, and for the past several weeks, they've been flooding it with drones. Cheap, expendable, and accurate enough to put a hole in a tanker or kill a flight deck crew. The US Navy has destroyers, Aegis systems, surface-to-air missiles that cost more than most people's houses. So why is the weapon actually stopping Iran's drones a 40-year-old helicopter designed to kill Soviet tanks? The answer tells you everything about how this war is actually being fought and who's winning it. But what exactly do you send to stop them? Not a frigate, not a fighter jet, a helicopter. The AH-64 Apache has been in American service since 1986. It was built for one mission: destroy armored columns before they could break through NATO lines in West Germany. That war never came, but the Apache stayed. And over 4 decades it's been adapted to every conflict the US has fought since. Now it's flying combat patrols over the Persian Gulf, operating off the flight decks of US Navy warships, hunting Iranian drones around the clock in one of the most strategically sensitive pieces of water on Earth. The base of operations is an American military installation in the United Arab Emirates. From there, Apache crews rotate through a constant cycle: land patrols, ship deployments, airborne alerts, maintaining unbroken coverage over the strait. When Iranian drones appear on radar, the response is already in motion before the threat can reach its target. The question is how you sustain that kind of operational tempo. How do you keep attack helicopters flying? Combat sorties, day after day, against an enemy willing to throw hundreds of cheap drones at the problem? The answer is logistics, and the scale of it is worth understanding. The detection sequence starts at sea. Radar operators aboard US Navy vessels in the Strait pick up the contacts first, classify them hostile in the Combat Information Center, and immediately relay targeting data to Apache crews, either already airborne on patrol or sitting on standby on the ship's flight deck. Standby crews start engines. Airborne crews turn toward the threat. The Apaches close, acquire the drones on onboard sensors, and engage. The 30mm chain gun under the nose handles close-range kills, high-explosive rounds, the same system designed to punch through the side armor of a BMP. It works on a Shahed. After the engagement, the helicopters return. Some back to the ship to rearm and wait for the next alert. Others back to the UAE base for a full turnaround. This cycle runs continuously. The rotation doesn't stop, which means the logistics chain underneath it can't stop either. On the ground at the UAE airstrip, the turnaround process is methodical and fast. Ground crews reload the 19-round Hydra 70 rocket pods, up to 4 pods per Apache, 76 unguided rockets per helicopter. The pods slide onto the stub wing pylons, locked in, each rocket checked before sealing. The chain gun drum is refilled with a fresh belt of 30mm. Then the AGM-114 Hellfire missiles go back on the rail launchers, laser-guided anti-armor weapons, each one slid onto the rail, connectors plugged in, mounting secured. An Apache that lands empty can be back in the air, fully loaded in under an hour. But sustained combat operations don't just wear through ammunition. They wear through airframes. Rotors, engines, hydraulics, everything accumulates damage under operational tempo. The solution is direct replacement. A U.S. Air Force C-17 lands at the desert airstrip nearby. On board is a replacement AH-64, partially disassembled for transport, rotor blades removed, tail rotor assembly broken down, stub wings and weapons pylons crated separately. The aircraft is rolled off the ramp manually, towed to the assembly area, and mechanics start rebuilding it immediately. Rotor blades attached, tail rotor mounted, stub wings bolted on, avionics reconnected and tested, full weapons load installed. Checklist clears, that helicopter is combat ready. The coverage gap it was meant to fill never appears. The Iranian drone campaign isn't random. Shahed-136s and similar one-way attack drones have been used against U.S. forward operating bases, Allied positions, and commercial oil tankers transiting the Strait. They're slow, subsonic, and cheap, individually, but they're deployed in swarms, and a single hit on a tanker triggers oil price spikes and insurance crises that ripple across global markets within hours. The Apache's role is interception before impact. It doesn't have the radar suite or the range of a naval surface-to-air missile system, but it operates at altitudes and in conditions where those systems have gaps. Low and slow, over cluttered sea lanes, in close proximity to commercial shipping, the Apache can engage where a standard missile can't. The Hellfire is overkill for a Shahed. The 30mm gun is not. And at the rate the patrols are running, the gun is doing most of the work. What's happening over the Strait of Hormuz is a live test of a concept the US military has been refining since the 1990s. Persistent, distributed lethal coverage maintained through logistics superiority rather than massed force. Iran's strategy with the drones is attrition and disruption. Flood the zone with cheap munitions, force an expensive and continuous defensive response, and hope the cost-exchange ratio eventually becomes politically unsustainable. A Shahed costs roughly $20,000. A Hellfire missile costs around $100,000. If Iran can force America to spend $5 for every dollar Iran spends, that's a strategic win even if every drone gets shot down. The Apache deployment partially answers that problem by using the chain gun, a low-cost per-round solution, as the primary kill mechanism against drone threats, reserving Hellfires for harder targets. But the deeper answer is the logistics system itself. The C-17 replacement pipeline, the round-the-clock rearmament cycle, the ship-based standby rotation. This is what sustains the coverage. Iran can manufacture Shaheds faster than any single weapon system can intercept them. The counter isn't a better missile. It's an infrastructure that never sleeps. The Strait of Hormuz patrol mission is an illustration of something that gets underappreciated in discussions of modern warfare: the gap between capability and capacity. The Apache is capable of killing drones. That's not the hard part. The hard part is being capable of killing the next drone, and the one after that at 3 in the morning, on day 47 of continuous operations, when the crew is tired and the airframe is worn and the spare parts are 3,000 miles away. The US military built a system here that solves the capacity problem. That's harder than building the weapon, and it's ultimately what determines whether a defensive posture is real or just theoretical. So what does a 40-year-old tank killer have to do with the future of warfare over one of the world's most critical waterways? As it turns out, everything. Because the Strait of Hormuz isn't just a geography problem, it's a logistics problem. And right now, America's answer to Iran's drone campaign isn't a new weapon system. It's an old one, reloaded and back in the air before the threat can reach the target. If you want to understand the full picture of how this conflict is being fought from the air, including how Israeli F-35s are operating over Tehran in one of the most complex strike environments ever attempted, watch our video on that mission next. The tactics involved will change how you think about stealth warfare entirely. Like, subscribe, and we'll see you in the next one.